So like most things we've done so far this year, we've drawn particle diagrams for a lot of the scenarios we're representing. So we're going to draw particle diagrams to represent strong acids and weak acids and strong bases and weak bases. So first, let's review what it means to be strong and weak. So if something is strong, it completely dissociates. This means that it's going to completely break apart into its two ions. So you're not going to have any of the original compound left. If something is weak, whether it's a weak acid or a weak base, it's going to not completely dissociate. So it does not So a weak acid or a weak base does not completely dissociate. This means that you're going to see both the original compound and the two ions in solution. Okay, so now that we remember strong versus weak, let's talk about acids versus bases. So acids are going to produce H plus ions, and bases we can think about kind of in two ways. It's going to produce OH ions, or it can accept H+. So no matter what, an acid is going to donate an H+. So you're going to see an H+ ion floating around. A base, you're either going to see OH ions floating around, or you're going to see that, they accept H+ or hydrogen ions. So let's look at a couple of examples. So my first example is HNO3. So we kind of have to decide, is this an acid or a base? Is it strong or is it weak? Okay, well HNO3 we know is on our list of strong acids. Which means we're going to see our HNO3 dissociate, and we're going to see it produce H+ ions. So when we're drawing a particle diagram for this, so if I have my box, I'm going to have my HNO3, that's going to completely break apart into its H+ ion and its NO3-. So in solution, I'm going to see H+ and NO3s. And they're going to be in a 1-to-1 ratio. So if I were to look at this particle diagram, I would know that it's an acid because I see H+ ions floating around. And I would know that it's strong because I don't see any HNO3. All I see are the two ions. Okay, let's look at another example. I'm going to leave my box. Let's look at C2H5OH. Okay, so C2H5OH is an acid, and it's not on our strong acid list, which means it's going to be a weak acid. Which means that it's not going to completely dissociate. So when we see this break up, we're going to see our C2H5O-. We're also going to see H+, but we're also going to see our original compound. So I'm going to see some C2H5OHs, but I'm also going to see some H+, and I'm also going to see some C2H5O-. So if I was given this particle diagram and I'm trying to decide if it's strong or a weak acid or a base, I see H+, that means it's an acid. And I see ions, and I see the original compound, which means that it's weak. Okay, let's do another one. So for my third example, I want to look at KOH, potassium hydroxide. Now, potassium hydroxide is on my list of strong bases. So that means it's going to completely dissociate, and it's also going to produce OH- or hydroxide. So we're going to see potassium ions, and we're going to see hydroxide ions, or OH minus. We're not going to see any potassium hydroxide because it completely dissociates because it's a strong base. And again, these are going to be in a 1-to-1 ratio because they're in a 1-to-1 ratio in their formula. So if I have 3 potassium ions, I have to have 3 hydroxide ions. Now, if I was given this particle diagram, I would know that it's a strong base because it completely dissociates. I don't see any of the original compound. And I also see OH minus or hydroxide ions, so that tells me it's a base. Let's do one more example. So if I have NH4OH or ammonium hydroxide is a base. It's not on my list of strong bases, so it's going to be a weak base. Which means I'm going to see 3 things in my particle diagram. I'm going to see my ammonium hydroxide, I'm going to see my ammonium ion, and I'm going to see my hydroxide ion. So I'm going to see NH4OH. I'm also going to see NH4 plus. And I'm also going to see OH minus. So if I was given this particle diagram, I know that it's a base because I see the hydroxide ion. I know that it's a weak base because I see ions and I see the original compounds. So that's how we can use particle diagrams to represent strong or weak acids or strong or weak bases.